Friends, so today we will learn about an interesting problem which has a daily life application too. So the problem name is stock span problem. What the stock span problem is, let's describe this. What we are given is a series of n daily price quotes for a stock. What a stock is a share, and price quotes are basically the daily price for that share. What we need to find? We need to find the span of stock's price for all n days. So let's look at this diagram. So this is day 0, this is day 1, this is day 2, this is day 3, 4, 5, 6. And on day 0 the price of stock is given by the height of this bar, which is h0 is equal to 10, h1 is equal to 5, h2 is equal to 1.5, h3 is equal to 3, h4 is equal to 1, h5 is equal to 4, and so on. So these are the prices. Now what we want to do is, so span on day I, we need to find the span for all n days, where span on day I, which is represented in short by SI, is defined as this, as follows: maximum number of consecutive days just before the given day for which the price of the stock on current day is less than or equal to price of stock on ith day. So the terminology might be confusing, but what it means is this. Like I will give an example and I will try to find the span for day 3, that is S3 in short. So S3 is the number of consecutive days just before 3 which have price less than on 3. So diagram wise we see the bars just previous, consecutive bars just previous to this bar having height less than this. So there is only one bar which is having height less than this, and the next bar is having a height greater. So S3 is equal to 2 because this index is 3 and this is 1, so value is 2. So S4 is similarly 1 because there is no bar which is height less than it. For this one, this has height less, this has height less, this has height less. So there are 3 bars having height less. So S5 is equal to 4 because 5 minus 1 is equal to 4. We subtract the indices. Okay, so that's the implication of this sentence. Let's try to look at the algorithm on how to find the span for each day, that is S0, S1, S2, S3, S4, S5, S6. We want to find all 6 of these, or in case of n days we want to find all Sn, like S0 up till Sn minus 1. So how to do that in linear time? Linear, that is On time. So to solve this problem, we try to make use of the stack data structure. Now how are we going to use the stack data structure? Let's look at that. What we do is, we use the stack data structure to solve this problem. As we keep getting new bars, we just push as far as we get lesser heights. As soon as we get a greater height, we pop till we get a lesser, here should be lesser. We pop till we keep getting a greater height and then we push. So this is correct. So what we do is, first let us look at these simultaneously. First, what we do is we push the 0th bar, which is having this height is equal to 10, which is the greatest among the all. Then we keep 1 aside. We look at the top of the stack, it is 0. So we compare h1 with h0. So h1 is less than h0, so it is not greater, so we need not pop. We just push h1, we just push 1. Look, we are comparing h0 and h1, but we are pushing only 1, that is the index. So this is just a one-way mapping. Array is kind of one-way mapping. Like from index we can retrieve the value, but from value we can't retrieve the index. So we push index so that in future we will be able to retrieve the value, as well as we will be able to use the index for the calculation of S, that is the span SI. Okay, so for this reason we are storing indices and not the values. Now 2 is aside. Now we compare S1 and S2. Again we push. So now we keep 3 aside. Now S3, as you can see, is of greater height than S2. So what we do is we pop 2. Again 3 is still kept aside and we compare it with 1. Okay. Now 1 is greater height than 3. So what we do is, okay, so push. Okay. Now we come here. Okay, let's look at it closely. Now 4 comes here. As we can see, 4 is of greater height than the top of the stack, which is 3. Okay, 4 is of lesser height, so we can easily push. So we push 4. Then comes 5. So the top of stack is 4. We compare h4 and h5. h4 and h5. h5 is greater. So what we do is we push, we pop h4, we pop 4. Next what we do is we compare the top of the stack, that is h3, with h5. Again we need to pop. Now we compare h1 and h5. Now it's okay, so we insert, because h1 is greater than h5, so it's fine. We can now insert. So we insert. Now we compare 6 with the top of the stack. Again h5 is less than h6, so we need to pop. We pop. Now we need to pop again, because h1 is also less than h6, so we again need to pop, and then we push, because 0 is greater than all of them. So finally we push 6 here. And one more important thing, each time we are pushing an element, that means we have obtained a greater element as the top of the stack. That's why we are pushing this element. So at that time we can output the value of Si as the index which is kept aside minus the index which is on the top of the stack. So 1 minus 0, here we give 2 minus 1, here we give this, these double circle things. Here we give this, here we give this, 4, here we give this. So these are the required answers. So we print the answers while we push an element. So it is printed meanwhile in this algorithm. So this is the representation, like we keep on popping until we find a wall which stops us. So like when we are keeping 5 aside, we'll pop, and this wall which stops us. So we are not popping anymore, we are just going to push, and just before pushing I will output 5 minus 1, that is 4. So S5 is equal to 4. So this is the crux of this algorithm. Hope you understand. Thank you friends.